Dear students, welcome to this YouTube channel. Today we have to discuss chapter number 3, Current Electricity. In previous two topics, we have discussed about the electric charge at rest. That one is electrostatics. Okay, so here current electricity means to study flow of charges. Okay, these are the electrical devices you can see in this picture. See, this current electricity is the branch of physics which deals with the study of charges in motion or flow of charge. Flow of charge between 2 points can take place only if there is a potential difference between them and conducting path. Suppose you take one conducting wire or one metallic wire. If you apply potential difference between its ends, then what happens? There is a flow of charges taking place through that conducting wire, and that one itself called as the electric current. So if you want to flow the electric current through a wire, means you have to apply potential difference. Cleared? Okay. The conventional direction of current is the direction in which positive charges flow, or opposite to the direction of flow of electrons. This electric current, or the strength of an electric current through a conductor or through a wire, is the flow of charge across a section of the conductor, and it is denoted by symbol I. I is the symbol of electric current. So if delta Q be the quantity of charge crossing the surface in delta t time, then current I is given by I equal to delta Q upon delta T, where delta Q is flow of charge in short interval time delta T. Is it clear? Okay. See, two more points regarding electric current. See, if the flow is constant, then we can calculate the current as flow of charge by time. If the flow is variable, then we can calculate current as limit delta t tends to 0 delta q by delta t, and that we can write as dq by dt, and this one is called as instantaneous current, means current at particular instant of time, and this can be calculated by taking the limit delta t tends to 0 delta q by delta t. Different types of current. See this graph. This one is the time, this one is the current axis. X-axis is taken as time axis, y-axis is taken as current axis. See here, the line which is parallel to time axis, this shows current is not changing or current is constant, and this current is called steady current, means constant current. See here, the line B, which is inclined with the time axis, but it is a straight line. Okay, so here current is continuously increasing or changing, and this one is not a straight line. This C is not a straight line. So in this graph, the line B and the curve C are getting, because of current is variable and whose magnitude varies with time. See one more graph, that is D. It is like a sine wave or cos wave. So means clearly it is periodic changing. Okay, so this current is called alternating current because whose magnitude varies continuously and direction changes periodically. This one is called as alternating current. Alternating current. In short, it is also called AC. So if the current is constant, we can say it is a direct current or DC. If the current is variable or varying continuously or periodically, it is called alternating current. But in this topic, we have to discuss about direct current. In chapter number 7, there is a special chapter. The name of the chapter itself is alternating current. We can discuss more about this alternating current in that topics. Okay, go for next. The SI unit of electric current is ampere because the current is charge by time. Charge is coulomb, time is in second, coulomb per second. Okay, 1 ampere means 1 coulomb per second. The current through a conductor is said to be 1 ampere if 1 coulomb of charge crosses any section of the conductor in 1 second. That is 1 ampere equal to 1 coulomb per second. So note, when a current of 1 ampere flows in a conductor, 6.25 into 10 to the power 18 electrons cross any section of the conductor, because in 1 coulomb 6.25 into 10 raised to 18 electrons are present. Then 1 coulomb of charge is flowing in 1 second means 6.25 into 10 raised to 18 electrons are flowing or crossing any section of the conductor. And one more thing, it is a scalar quantity, but it has direction, only 2 directions along the conducting path. Okay, but it is a scalar quantity, remember. Let us to discuss the term drift velocity and current. What is this drift velocity? See, when an electric potential difference which is applied between the conductor, what happens? The electrons or charges which are flowing through that conducting path or through that wire, and this flow itself called as the electric current. and the flow of charges in a conductor means flow of electrons in a conductor, and these electrons will not move in a straight line. Remember, they move inside the conductor in a zigzag path, and the average velocity of the electron itself called as the drift velocity. That is, drift velocity is defined as the velocity with which the free electron get drifted towards the positive terminal under the effect of the applied electric field. See, this one is the conductor of length L having cross sectional area A be the cross sectional area, L be its length. We can apply the electric field with the help of cell or battery by connecting two terminals of the battery to the conductor. Suppose the positive terminal of the battery is connected to the conductor left side, and negative terminal is connected to the conductor at right side of the conductor. So potential difference, let the potential difference is V. So then what happens? The electric field will be existing. We have already known the relation between electric field and electric potential. If the potential difference is V, okay, then we can write the electric field E equal to dV by dl, and in this case V divided by L. Electric field is V divided by L. Okay. See, when the field is applied, the electrons will start moving from right to left side, because the positive potential is applied towards the right side and negative potential is applied towards the the positive terminal of the battery is connected to the left side of the conductor and negative terminal is connected to the right side of the conductor. So the electrons will move towards the positive potential, that is towards left side. So, and this velocity is given by acceleration into time. But we have already known what is acceleration means, change in velocity by time. Actually, the electrons, its initial velocity is 0. Okay. If you apply the potential difference, the electrons will get drifted. So hence the change in velocity itself is the Vd. That one is the drift velocity. So that drift velocity we can calculate, or we can write it as acceleration into time, where tau is the relaxation time, means how much that will it will take, how much time taken by the electron for conduction or to drift the electron. Okay. So now we have already known what is this acceleration. Acceleration means force per unit mass. Acceleration means force per unit mass, and we have already known force means charge into field. So we can write in place of acceleration E into capital E. Small e is the charge of the electron and capital E is the electric field. So this one is force upon m. M is mass of the electron. So in place of A we can write small e into capital E divided by m. This gives the acceleration of the electron into t, time. Okay. So now finally we can write the electric current as NEA Vd, NEA Vd, where N is electron density, where n is electron density and A is the cross-sectional area. Okay. This implies, or from this relation we can say, current is directly proportional to drift velocity. If current is more, its velocity is also more. See the term, Vd means drift velocity, A means acceleration, tau means relaxation time, means it is the time taken by the electron or the average time elapsed between two successive collision, and E is the electric field, small e is charge of the electron, and m is mass of electron, n is number of electron present per unit. That one is called as electron density or number density of electron, and L is the length of the conductor and A is the cross-sectional area. Okay. Now let us to discuss one more term, mobility. What is this mobility? See, if you apply the electric field, the electron will get drifted. Okay. This drift velocity per unit electric field itself called as mobility, and it is denoted by symbol mu e. So the mobility of a conduction electron is the drift velocity per unit electric field, and it is denoted by symbol mu e. Cleared? So mu e equal to Vd upon E, that is small e into tau divided by m. Is it clear? Okay. The SI unit of mobility is meter square per volt per second. And one more thing you have to remember, mobility is positive. Okay. Thank you.